My name is Agung Dwicahyo. I come from the city of Ponorogo, Java, Indonesia. I am a student of the Sebelas University Surakarta. I want to present my proceeding with the title Development the Prosthetic Hand by using UBEC for Hand Disabilities Amputee. Introduction. World Health Organization or WHO claimed that more than 1 billion people are estimated to live with some form of disability. 15 15% of the world population to 190 million or 3.8% people aged 15 years and over experience physical disability. Human must involve and human must involve their hand every day to carry out their activity. The absence of hand describes daily activities such as carrying things, lifting items, and putting things down. So we need to get able to assist in carrying out daily activities to help with amputee disability. One of the development in aid of amputee disability is the robotic hand, but it still has shortcomings in the actuator system, which requires extensive strong. As for rehabilitation to restore self-confidence after amputation, however, it takes time and it is necessary to visit the rehabilitation center. One of the health sector technologies to help with amputee disabilities is the prosthetic hand. Prosthetic hand, a tool that concentrates on the replacement of a lost hand to uh, prosthetic hand, a tool that concentrates on the replacement of a lost hand due to amputation. Research on prosthetic hand at the Sebelas University Product Planning and Design Laboratory or Laboratorium P3WNS has researched prosthetic hand. Still, still it has a weakness in the power supply system, which is wasteful with batteries energy source. This result aimed to test the prosthetic hand power supply system using UBEC as a power supply system powered by battery. Research on prosthetic hand at the Sebelas University Product Planning and Design Laboratory or P3UNS start a long time. Tested the signal capture using a signal channel melodic signal frequency module. Then it was development pamungkas by examining the melodic signal capture procedure using a three-channel melodic module based on the AD620 by attaching the electrode to certain portion on the skin of the hands. Hartono developed a fuzzy-based control logic to classify the type of grip on the low-cost anthropomorphic prosthetic hand based on melodic parameters. Then it was set again by Rahman by design a fuzzy-based control system using melodic parameters. This this test used a prosthetic hand and an energy source from a 4000 mAh lipo battery. Measurement to with a 4-meter type Mayfair DT9205A, DT830D, and Weiner brand DT860D. All of the steps carried out in the research are as follows: a prosthetic hand design system, B. Retrieval of data. Prosthetic hand design system. This study used a prosthetic hand researched by the Sebelas Maret University Product Design and Planning Laboratory or P3WNS. The cable system is a system used to move the finger joints in the prosthetic hand. The prosthetic hand component use an Arduino-based microcontroller circuit, electromyography, EMG sensor, servomotor, batteries, and the ultimate battery eliminator circuit or UBEC regulator. B. Retrieval of data. Data collection was obtained through two stacks of prosthetic hand testing. The first test checked the servomotor. The servomotor is tested to determine the condition of the servomotor. The second test is to install a microcontroller, MG sensor, regulator ultimate battery eliminator circuit or UBEC, and batteries. This research data collection has been completed as described in the previous discussion. Table 1 shows the current measurement when one finger move and the five finger move. While table 2 shows the voltage measurement. Table 1 current measurement result of conventional regulator and UBIC regulator. Current measurement of conventional regulator and UBIC regulator in table 1 show that the outflow magnitude is almost identical. The difference in the flow of one finger with five fingers is minimal, and a slight difference in current occurs in the two regulators. Picture 1 graph of current measurement for conventional regulator and UBEC regulator. Figure 1 shows the difference between the two regulator current. The blue line is the UBEC regulator measurement, and the orange is the measurement for the conventional regulator. Size of one finger at 0 until 5 minutes cause a difference, where the traditional spec of regulator current is lower than the UBEC regulator. The striking difference in current only occurs in 0 until 5 minutes, but in 10 until 30 minutes, the difference between the two regulators is almost the same. Table 2 result of measurement of voltage regulator conventional and regulator UBEC. The measurement of conventional voltage regulator and UBEC regulator in table 2 has difference. The measurement for the measured voltage is a big difference when moving one finger or five fingers. Conventional regulator measured around 4 volts and UBEC regulator measure about 5 volts. Figure 2 graph of measurement of voltage regulator conventional and regulator UBEC. Figure 2 shows the voltage difference between the two regulators. The blue line is the UBEC regulator measurement, and the orange is the conventional regulator measurement, measuring the voltage at one finger and five fingers. Conventional regulator experience a voltage drop of up to 4 volts, unlike the UBEC regulator. The measured voltage remain in a stable state of about 5 volts. The voltage drop that occurs in the conventional regulator result in a the voltage drop that occurs in the conventional regulator result in inefficient battery energy, so that the battery energy in the process hand cannot last long. Battery energy in a process hand can be more efficient using UBEC regulator as step-down regulator for microcontroller. EMG sensor and servo motor, whose energy source come from the batteries. Conclusion: the prosthetic hand design in adjusting the power supply system to move one finger and five fingers. The UBEC regulator as a step-down regulator has been tested by the method described. The conclusion drawn from this research is the UBEC is a regulator that can stabilize the voltage in case of a short and maintaining a stable voltage of about 5 volts. The UBEC regulator proposed that the energy source in Prosthetic can be more efficient. In the subsequent research, it is hoped that the servo motor will have a light weight but have good performance. Thank you very much.